Builders, Pranav here. If you're developing services, AI agents, or even dApps that need to perform on-chain actions programmatically and securely, this video is for you. Today, we are developing a crucial piece of infrastructure, a backend wallet service using Node.js Express and the official Coinbase CDP SDK. This backend service will securely manage CDP API credentials and expose simple API endpoints. This means your other applications, AI agents, or even dApp backends can request wallet creation and transaction sending without handling the CDP secrets themselves. We'll use AI code editors like Cursor or Windsurf to build this efficiently. A quick note on LLMs and this new SDKs. Since CDP API v2 and its SDK are fairly new, an LLM might not have full information regarding it. Prepare a context file or information piece regarding the CDP SDK using the official Coinbase developer platform docs so that you can feed this to the AI before prompting. We'll link to a similar guide in the description. In this video, we'll cover scaffolding a new Node.js project with Express using AI Assist, securely initializing the Coinbase CDP SDK, using AI to generate endpoints for creating general service managed wallets, creating or retrieving user-specific wallets for the DApps, funding these wallets using the official CDP Faucet, and also doing concurrent batch-eth transfers using this service. Performing a final AI-assisted code review, discussing vital production considerations, and how this service becomes a cornerstone for various automated services. Let's get the AI coding partner ready and build this. So first of all, let's get set up with the project environment. So I already have my AI coordinator open over here. I'm using Windsurf. You can use any AI coordinators that you like. I already have the context document as well, and I have created a folder for our project, CDP Wallets Backend. You can use any name you like. And so first of all, we'll attach the context document and the documentation. So um, the context document, and also this AI core editors have a special plugin for documentation as well, which we can use so that the LLM can go through the documentation for various SDKs and tech stack as well. So we have a special plugin for here in Windsurf where we can use the Coinbase Docs plugin, which is an auto plugin with Windsurf. So I can just attach this as well so that it can go through Coinbase documentation as well. Once that is done, I will give my prompt as well, which will say to set up a basic project using Express and TypeScript. So I have the prompt which says initialize a new Node.js project with npm, create a basic Express add with TypeScript, include dependencies, add dev dependencies, configure tsconfig, and package.json with the type module. So once that is done, I will hit enter. So let's accept all of these. So first of all, npm initwise, then dependencies. And we are done with that as well. Then the bow dependencies. Then with that, then the teams config. Then with that as well. It needs to create an SRC directory where all of the project folders would reside. Let's do that as well. Let's go through the changes ones. So we have the package.json changes. Let's accept this. Scripts changes as well. We have tests, the start and blue scripts. Next, we have, let's go to the next file. We have the envs. Let's accept this into over here. Then we have package of this one. Let's accept this changes in here. Next, we have our index.ts, which has some basic commands. So that's it. We are done with the basic project setup. Now we can move to the next step. So once that is done, we have set up a basic Express project. Now we can move to our next step, that is to set up a basic CDP client. So I already have the prompt over here. So first of all, in SRE server TS, set up a basic Express app. It is already done. Create a separate module CDP client, which exposes Initialize CDP client and get CDP client with all of the secrets and the initialization of the CDP wallet. Also, we remember to add the context as well. That's very important to make sure that the LLM doesn't deviate from the correct resource. So already have the context documents for LLM. We'll add the Coinbase docs as well, which we mentioned before. So once that is done, we'll hit enter. Please just accept this comment as well. So that's done. We just need to add the env variable. So let's go to the CDP client. So we have the CDP client as well, which looks good. We can remove this. Is this is not, we can automatically get the CDP secrets from the env as well. Once that is done, we'll accept these changes. This looks good. A- CDP API key ID, CDP API key secret, CDP wallet secret, and here the server TS changes. We'll accept these changes as well. Here's some bracket dot this some changes, and we'll add the env secrets over here as well. So once that is done, we are done with the project environment setup, and now we can move on to setting up the main logic of this backend. So our backend service provisions CDP wallets. While CDP secures the keys, we still need to handle other properties like addresses and the various properties of a wallet and associate them with a particular identity. Like for dApp users, it could be username, or for internal bots, it could be a service ID or something like that. So for production, always make sure to use a database, but we will be using an in-memory array over here so that we can quickly go through this demo and learn the essentials. But this is something you have to make sure that you associate the each wallet with a user using special identifiers like username or service IDs for bots or AI agents. So make sure you do that. So now let's create our first API endpoint, which should basically create general service managed wallets for internal bots or AI agents. So make sure that we are using a specific identifier for each of these wallets created so that we can specifically identify all of these wallets and see how all of these wallets are assigned. So we'll make sure that this is done by specifying this in the prompt that we are going to send to the LLM. So first of all, we'll attach the context documents. So we have a context documents as well. Next, we will attach the Coinbase docs. Coinbase docs. And we'll also attach our project over here. So the directories, and then we have the project. Next, we have the prompt. So let's go through this prompt once and see what it specifies. Create an express async post for root/wallets. It should get name assigned to from request body, validate assigned to, and call get cdp.client.evn.create account with a distinct name, and create a managed wallet object, store it in the managed wallet store, and respond to 01 with new wallet details. So here we are just using an in-memory array for demo purposes. Make sure you're using a proper database in production. So let's hit enter. So now we are done with the implementation. So let's first of all review the code given by AI to make sure that everything is correct. So let's accept the changes. So this one looks good. So we have the first interface manage wallets, which takes some essential parameters. We have the middleware as well. So we have defined the handler as well. So I don't think so this comment is needed. We can just remove this. So AI has a tendency to do unnecessary comments on project files. So I'll be making sure all of these comments are not there in my project file. So here you can see another example of the same. So let's remove this comment. And I can see the account name is not addressed over here. One, I think so this is a mistake made by the LLM. Let's add the account name over here. So we can add account name over here. So once that is done, make sure this is done properly. And once that is done, we can now again a lot of useless comments. Let's remove this as well. So here you can see it's using the context that we provided, which is a good sign. So now let's remove this as well. And we have a account ID, we have addresses. So store in memory for now. So this looks good. We have done some corrections as well. So always make sure that you are reviewing this AI generated code to make sure that everything is correct and all the implementations are properly done. Now let's move on to the implementation of a second API endpoint, which would get or create user managed wallets for dApps. So our last API endpoint was for AI agents for internal bots. This time we are creating an endpoint for user managed wallets so that dApps can directly request this API and get or create user managed wallets for their DApps. So now let's get started. So I already have the AI editor open over here with the cascade. Next, we'll add the context. So let's add the context document. We'll mention this is the context document. Context for CDP SDK. Next, we'll add the Coinbase SDK as well. Coinbase Jocks SDK. And next, we have the prompt. So let's go through this prompt and see how it works. Create an express async post route slash user slash wallet. It should get username from request body, validate username, construct a unique internal wallet name for CDP, check manage wallet store if a wallet with this unique name already exists. If exists, it will return 200 with its detail. If not, it will call .evm.create account using the unique internal wallet name, store the new managed wallet, and respond to 01 with details. So that sounds perfect. Let's enter. So it's done with the implementation. Let's review it once. So it has successfully added a user identifier to the interface. Next, we'll move on to the actual route implementation. So first of all, it takes username from request.body. It checks if a wallet for this user already exists by going through manage wallet store using the find functionality. Then it checks if the existing wallet is there. If it's there, it will return a status 200 with the existing wallet details. If not, it will create a new wallet. First of all, it will initialize the CDP client, then create an internal wallet name, then use the CDP client.evm.create account to create a new account with the internal wallet name. A network is already configured, so we can remove this comment. Next, we initialize an account ID, and then we push the manage wallet store array with the managed wallet details, and then we console log the wallet details and return a status 201 with the managed wallet details. So this implementation looks good. So we can hit accept changes over here. So now we are done with the second API implementation as well. Now we can move on to the next API implementations. Now let's implement a third API endpoint which would fund all of these wallets using the official Faucet on testnet. So let's move on to the implementation. Already have the cascade and the AS LLM setup over here. So first of all, we'll add the context for CDP SDK, then we'll add the Coinbase docs, then we'll add the prompt. So create an express async post route, which would take a wallet address as a parameter and slash Faucet. It should get wallet address from the path, validate it and check if it's managed by a service for the specified network. Get network if not specified default base Sepolia and token if not specified default ETH from request body. Call get CDP client.evm.request Faucet. Wait for confirmation, respond with transaction hash and secrets, and handle Faucet or else like already requested. So also this one, you click enter. So the AI is done with the implementation. Now let's go through it and review it once and see how it works. So we have set up a VM client for base Sepolia as our current server works on base Sepolia. So, and this Faucet API would be specifically for base Sepolia for demo purposes. So we'll set up a basic VM client with base Sepolia. So VM public client with create public client, and chain would be selected chain base Sepolia. Next, let's move to the API implementation. So basically, we have this slash wallets Faucet, which would take wallet address as a parameter. So const wallet address request parameters, and then we have the request.body parameters. After that, we'll do some normal checks to make sure that wallet addresses are properly set up and the network is base Sepolia. And we are keeping this to base Sepolia and with as of now, this API implementation. And after that, we get the CDP client. We find the managed wallet from the array. And if we do not find this, we throw an error. Once that is done, we use a CDP client.evn.request Faucet with the address, network, and the token parameters. Once that is done, if the Faucet transaction doesn't go through, it will show an error. If it goes through, it shows the transaction hash and uses VM to wait for the transaction to zip. So basically we will use the wait method from the VM to wait for the transaction to complete. Once that is done, it will show the success parameter if it's a success, and if it's an error, it shows the faucet transaction error, and it tries to catch other errors as well, like limit exceeded or rate limits or anything like that. And if it has an insufficient funds error or unsupported faucet, etc. So covering these various error cases, make sure this API implementation is robust. So that's also done over here. So this implementation looks good. Now we can move to the next API implementation and see how it works. So now let's move on to the final and the most important API implementation for this backend service. Will we implement a batch ETH transfer API endpoint for this backend service? So basically, this would take multiple recipients and transfer ETH concurrently to all of these recipient wallet addresses. So let's get to the implementation. So I already have the TypeScript set up. So first of all, we'll add the context. So inbox. So let's U2. Next, we have the server.ts. For safety, let's have the whole SSC folder as well. Next, we have the prompt. So this prompt would be a bit large because there's a lot of information that we need to provide to the LLM so that this implementation is as near perfect as possible. So let's go through this prompt and see how it describes the API endpoint to the LLM. So create an express async post route, send batch it. This endpoint should retrieve sender address parent from the URL path and recipients and network from the request body. Validate all inputs, ensure sender address parent and each address in recipients are valid Ethereum addresses. Amount per recipient is a positive number and recipient array is not empty. Verify that the sender address param corresponds to a wallet managed by the service on the specified network. Convert the amount per ETH from recipient string to its V equivalent for each recipient address in this recipient's array. Prepare and submit an ETH transfer transaction using get CDP client.evm.send transaction. This submission should be handled concurrently. So as you can see, we are describing the API endpoint in steps to make sure that the LLM has all the context regarding this API and implementation. Next, we implement a retry mechanism with exponential backoff for transaction submission in case of rate limit errors from the CDP SDK. After getting all submissions, collect the transaction hashes for successfully submitted transactions. For each successfully submitted transaction, use VM public client.wait for transaction receipt to await for its on-chain transformation. This receipt waiting operation should also be handled concurrently. Next, finally, we compile a summary of the results, including the status for each recipient. Respond with a JSON object detailing the overall outcome. We'll ensure robust error handling throughout the process. So this prompt should be well enough for this LLM to understand all the context regarding the endpoint. So it's hit enter. So the AI is done with the implementation as well for the send batch each transfers. Let's go through the changes and see how the AI has implemented the changes. So first of all, it has imported a bunch of utilities from VM, as you can see. So first of all, we have pass ether, we have seedless transaction, create public client, and various other utilities from VM so that we can handle the concurrent transactions that we are processing through this API endpoint. And we are using base Sepolia as we have restricted this backend to base Sepolia as of now. Again, we have restricted the backend to base Sepolia for demo purposes. Next, we have the VM chain map. So we only have base Sepolia address over here. So we'll keep this only to base Sepolia. Next, we have the batch transaction result interface, which would define the batch transaction results for the API endpoint. So we would have the recipient submission status, transaction hash, submission error, confirmation status, receipt, and confirmation. Also, these are the basic parameters that are received from the transaction hash and its parameters itself. Next, we have the max retries. So these are the max retries that the API endpoint would take if the transactions are failed or the nearest. And this is a base delay as well. So in MS, which we are kept to 1000 as of now. And we have kept a sleep function for setting the timeouts for the function implementation. So that's over here. Now let's move on to the main route implementation as we're done with the utility implementations. So we have the implementation over here. So wallet slash parameter wallet address send-batch-eth. So this would take sender address param request dot parents dot wallet address and all the recipients and the amount per recipient with in the request body, and the recipients would be converted to a array of strings and the amount per receipt as a string. Next, we invalidate the inputs. We make sure that all of the inputs are properly set up. The address is in the proper format and the arrays are properly set up as well. So these are the basic input validation. Then we'll find the managed sender wallet. So we'll go through the array and find the managed sender wallet. Once that is done, we will make sure that the sender wallet is present. If not, we'll send neither. And then we'll convert the amount to way over here so that we can process the transaction using VN. So let amount way begin, and we'll pass it using pass to the function. And if there are any errors, it will make sure the errors are properly passed as well. Next, we'll get the VM chain and create the public client. So we'll get the VM chain map for base Sequoia and create the public client over here. So we'll just be creating the VM client for base Sequoia, the transport HTTP. Next, we get the CDP client and use create another variable for results with the batch transaction result interface. And then we map recipients to an array of promises for cdp.evn.send transaction. So as you can see over here, we are mapping the recipients over here for cdp.evm.send transaction. And we are using the serialized transaction VM utility to serialize all of this transaction properly. Non-send gas parameters are handled by SDP CDK as we have discussed before. So let's remove this comment not needed. Once that is done, we'll keep the retry count to 0 to make sure that the retry count is properly set up. And then we set up an while loop where we attempt to send the transactions concurrently. So we use the cdp.evm.send transaction for each of the wallet addresses, and these transactions are sent concurrently using in this while loop. Here we have some calculations regarding retry count and delay. So basically, we do an if check to make sure that the retry count and delay are properly set up. We increment the retry count after the transactions, and then we do up the delay calculations, and then we do a console.warn as well to make sure that the rate limit console logs are done properly as well, and then we have the sleep functionality. Then we use the promise.all-settled for submission. So we'll use the promise.all-settled functionality so that we can settle all the promises. And then we get the receipt for all of these promises. And for each of this receipt, we make sure that all of these transactions are properly set up and the promise is properly set up for all of the receipt. And we can wait for all of these transactions properly so that we can fetch all of the transaction hashes, and if the transaction went or not, or if there are any errors in the transactions. So we'll create a promise to wait for the receipt, and that's the logic over here. And if the submission is failed, we make sure that the errors are properly set up and shown in the consoles as well. Next, we will await all of the receipt promises that we did before, and we use for each for going through all of these receipts, and we will await all of these receipt promises to make sure that all of the transactions that went through are properly shown in the backend and properly registered in the backend. And next, we'll log this all of this summary and return the JSON responses using the res.stash to 200. So this was quite a huge function with a lot of functionalities in this. But basically, we were concurrently sending transactions, and we were using JavaScript's promise functionality over here to make sure that all of these transactions are handled properly. With that, we are done with the implementation of the backend service. Now we can move on and test this backend service by running all of these APIs. Now that we are done with the implementation of our backend service, let's test out the various APIs that we have implemented. So I have already started the server over here, and I'll be using Postman to test out these APIs. So let's test out these APIs and see how this works. So I'll just change this to something like this, and we can do something like this just to make sure we have different implementation. Let's keep this mode to 3. Okay. So let's send this request and see if this works or not. And yes, it worked. So we were able to successfully create a wallet for this user, and the wallet ID is test user with the address, network name, and the various other details. Next, we go to the user wallet where we do this, where we create or get a user wallet based on its username. So I'll just write my name over here. Let's send this. And yeah, we were successfully able to create a wallet using this method as well, with the same details like wallet ID, address, network name, and with user identifier as well, dApp underscore user underscore promo. Let's note this address so that we can use this in our further API tests. So I'll just copy this. Next, let's request some funds from the faucet. So first of all, I'll change the value of this address over here. So once that is done, I'll move to the body. This looks good. Let's send this transaction. And yeah, there were no issues with this as well. We were able to successfully send the API request, and we got the faucet funds, and it got confirmed as well. Let's do this more so that we can get enough funds for our next send-batch-eth test as well. Let's do this 5 times. There should be any issues. Oh, and so, yeah. This should be enough funds for our next test where we would be sending some batch ETH using this API. So again, I'll just replace the address, and that's done. We have the amount per receipt as well, and we have some receipt as address as the recipients as well. These are just my test addresses. Now let's see if this works or not. So and yeah, we were successfully able to send batch it using this API as well. So you can see batch transaction process initiated with total 2 recipients. It shows all other details. So all these details are procured from the transaction has like other L1 fees and stuff. So this wouldn't be basically needed in the dApp. You can just ignore all of this. You can just take all of these parameters that are needed for your dApp, like status, to transaction hash, and next, it would show all of the other details as well, like recipient, submission status fulfilled, and various other statuses. So you can just get the transaction hash for your dApp so that you can show in the dApp that the transaction was confirmed. So yeah, that's it. You were able to successfully test the transaction as well. Let's go through the server logs as well once and see if everything's good over there. So we have the server logs over here. So everything looks good over here. The faucet transactions also went through, and the various batch transactions also went through with successful transaction hashes. So this looks good. The testing was successful, and that's it. That's the CDP backend service implemented. Yeah, it's a demo is a great start, but production requires more. First, written authentication and authorization. Securely identify services that are trying to access your API services. Map identities to wide permissions. Second, secure credential management. Use secret managers to safely secure your credentials while working in production. Third, persistent database. Use database storages like MongoDB or SQL while working in production. Fourth, structured logging and monitoring. Use structured logging while working with production code bases. Fifth, rate limiting. Implement rate limiting for your sensitive API endpoints. Six, proper error handling. Make sure you're using proper error handling techniques while working with production code bases. Seventh, asynchronous transaction processing. For send endpoints, immediately return the transaction as is. Handle these transactions asynchronously. 8. Gas management. Use a gas price oracle for secure gas management. Ninth, wallet security and segregation. Use different wallets for different wallet profiles. Make sure you're using strict access control for all of these wallets. All of these points are crucial for a reliable, secure, and scalable backend service. Building a backend wallet service like this powered by Coinbase Server Platform Wallets and its SDK is a robust way to integrate on-chain capabilities programmatically across your internal systems. The TW-based security for key management and its SDK simplify many traditional complexities. This is just a foundation. Explore more. Implement smart accounts and ERC-23 transfers throughout the backend service, or implement more sophisticated wallet management, policy controls, or internal audits throughout the backend service. The capabilities of CDP Wallet Suite 2 are truly designed to empower builders building serious on-chain applications and backend infrastructure. I hope this blueprint gives you a very good starting point. I highly encourage you to check out the Coinbase Java platform documentation, the Coinbase CDP SDK GitHub for more such examples, and hindlabs.com for more such tutorials. What kind of internal wallet service or automated on-chain system would you build? Let me know in the comments. If this detailed walkthrough was valuable, hit that like and follow us as well. Thanks for building with me today. See you in the next one.